Hello everybody, how are you? Hope all of you are fine. In my last class, I discussed up to the formation or preparation of acid. Today I will start from properties of acid. We know that different substance has different taste. So acid also has different one special type of taste. Generally acids are sour in taste. If we take any citrus fruit like lemon, orange, they are generally sour in taste. All organic acids are edible and we can take taste and they are sour. But we should not take the taste of mineral acid because they are very much dangerous. Next we will discuss the action on skin. Mineral acids are corrosive to skin and clothes, but organic acids are edible. If acids fall on your skin, especially concentrated sulfuric acid, concentrated nitric acid or concentrated hydrochloric acid, then we should not wash with water. First we have to clean with a piece of cloth, then we have to add or we have to apply a paste of sodium bicarbonate. Otherwise, if we add water to dilute it, then its degree of dissociation will increase and its action will be higher and it will damage our skin very rapidly. Next we will discuss the effect of electric current. We know that acids, when it dissolves in water, dissociate into ions. Like HCl will dissolve into water, that will produce hydronium ion plus chloride ion. Any acid, sulfuric acid will dissolve to produce hydronium ion and sulfate ion. So there will be free ions. We know that free ions can carry current. So acid solution, that means aqueous solution of acid, is a very good conductor of electricity. Next we will discuss the action of indicator. We know that indicators are indicating the substance whether it is an acid or base by changing their colors. If we take blue litmus, then blue litmus turns into red in presence of acid. If we think about phenolphthalein, it will remain colorless in acid solution. Methyl orange turns orange to pink in acid solution. Universal indicator, that is a mixture of dyes, organic dyes, it will turns red in acid solution. So in this way, in acid solution, different indicators will show different colors. From there we can easily judge whether the solution is acidic or basic. Next we will go that neutralization reaction. Acids generally undergo neutralization reaction with base. If we take any acid like HCl, it will react with base to form salt and water. Sorry, NaOH will form NaCl plus H2. So this one is an acid, this one is base forming salt and water. And this type of reaction will produce heat. This is exothermic reaction. And any acid or base equivalent amount will react to form salt and water, and this is called neutralization reaction. Next we will discuss the reaction of acid with active metals. We know that metal activity series, the metals which are placed above hydrogen in the metal activity series, that will react with dilute acid and form hydrogen gas. If we take zinc will react with dilute sulfuric acid, that will produce zinc sulfate, salt plus hydrogen gas. Now this is a single displacement reaction. Here zinc displaces hydrogen from this acid and producing hydrogen gas. We can think about magnesium, iron, these all metals are active metals. They will react with acid forming hydrogen. But sodium, potassium are highly active metals. and they will react with acid vigorously to produce hydrogen gas. There are some metals like platinum, gold, they are called noble metals. They do not react with acids because they are very much less active. Next we will discuss the properties, that action of dilute acid on different types of salt. First we will discuss that carbonate salt. If we take carbonate salt and add acid, that will form salt plus water plus carbon dioxide. If we take bicarbonate also, that will also react with acid, forming salt, water and carbon dioxide. So first we are writing this equation, that sodium carbonate is reacting with acid, forming NaCl plus water plus carbon dioxide gas. If we take sodium bicarbonate, that will also react with acid, forming NaCl plus carbon dioxide plus water. So carbonate bicarbonate salt will produce carbon dioxide after addition of acid, dilute acid or concentrate, no problem. Next we will discuss that sulfide. Metal sulfide will react with acid, forming salt, water and sulfur dioxide gas. Or if we take metal bisulfide, that will also react with acid, forming salt, water and sulfur dioxide gas. First we are taking that sodium sulfide, Na2SO3, that will react with acid HCl, forming twice NaCl plus SO2 plus H2. So in this way, if we take bisulfide also, same thing will happen. It will produce salt plus water plus carbon dioxide. But if we take sulfide, metal sulfide will react with acid to form salt and hydrogen sulfide gas. If we take ferrous sulfide and if we add dilute sulfuric acid, that will produce H2S gas plus ferrous sulfate. So this is the laboratory preparation process. Okay, in our lab, if we want to prepare H2S gas, we have to take ferrous sulfide. Then if we add dilute sulfuric acid, that will produce hydrogen sulfide gas. Generally, Keep apparatus is used to store this type of hydrogen sulfide gas during analytical experiment of different types of inorganic salt. So these are the properties of acids. Next we will discuss one important thing about acid, that is acid rain. Sometimes in rain there may be presence of acid. The presence of excess amount of acid in the rain is known as acid rain. Acid rain generally contains different types of acid like sulfuric acid, sulfurous acid, nitric acid, nitrous acid. Now what is the cause? If we burn sulfur, then there will be formation of sulfur dioxide. And in air there is also nitrogen. So this nitrogen, when in lightning time, there will be formation of nitric oxide. This nitric oxide again will convert into nitrogen dioxide, and nitrogen dioxide again will convert with nitrogen trioxide or NO3. Now this will react with each other, that will form N2O5, and finally N2O5 will react with water to form nitric acid. I am showing you the reactions how acid rain is formed. In different types of industry, they are using nitrogen and sulfur compound. So they are byproducts of the oxides of nitrogen and sulfur. So these are very much corrosive, and this causes the acid rain in our nature. So first, sulfur will react with oxygen, that will produce sulfur dioxide gas. Now this sulfur dioxide gas will be present in the atmosphere, will react with the acid rain, forming sulfurous acid. If there is formation of sulfur trioxide, that means sulfur dioxide is there, that will again react with oxygen, forming sulfur trioxide, that will react with water to form sulfuric acid. In this way, rain contains sulfurous acid and sulfuric acid. If we think about nitrogen, nitrogen is present 70% in our atmosphere, that will react with oxygen when there will be electric spark or lightning or at higher temperature. In industry they are using higher temperature, okay, that time there will be formation of nitric oxide. That nitric oxide will react the oxygen presence in air forming nitrogen dioxide. Now this nitrogen dioxide again react with oxygen forming NO3 plus this nitrogen dioxide again react with oxygen forming NO3 plus O3, that is ozone. Now these NO2 and NO3 will react each other to form N2O5, nitrogen pentoxide. This nitrogen pentoxide will react with water to form nitric acid. And this NO3 also react with water to form nitric acid plus nitrous acid. NO2 nitrogen dioxide will react with water to form nitric acid and nitrous acid. So in this way different types of acid will produce and that will precipitate through rain and it will come to our earth. Now what is the bad effect or harmful effect of this acid rain? Acid rain increases the acidity of the soil and reduce the fertility of the soil. So the growth of the crops will be decreased. This acid rain destroys marine life due to change of the pH of water. Actually pH will decrease. pH I will discuss later. Next, this acid rain can corrode marble structures. We can think about our Taj Mahal is made of marble. If there is acid rain, that will be corroded. There will be black patches on marble stones. Next, this type of acid rain cause rusting to the metals like iron or different types of active metals that will react with this acid to form corresponding salt and hydrogen gas. So these are the bad effects of acid rain. Now we have completed the discussion of acid. Next we will start bases. Now first we have to understand what is base. According to the Arrhenius concept, a base is a substance which dissolves in water and gives hydroxyl ions in aqueous solution. If we think about KOH, potassium hydroxide, if we take water, that will dissolve and form K plus and OH minus. So as KOH is producing OH minus or hydroxyl ion in water, that is why it is called base. We can think about ammonia. Ammonia will also react with water, forming NH4 plus OH minus. As it is producing OH minus in water, so it is also called base. Now water soluble base are called alkali. If we think about copper hydroxide, if we think about ferrous or ferric hydroxide, they are not water soluble base. Okay, so these base we cannot say they are alkali. Only water soluble base we can tell they are alkali. So one conclusion that you have to understand, that all alkalis are bases, but all bases are not alkalis. Next we will discuss the classification of base. Next, classification. If we think about the acidity of a base, acidity of a base is the number of replaceable hydroxide ions present in an acid. If we think about sodium hydroxide, that will react with HCl, forming NaCl and water. So in this reaction, one OH minus is replaced by HCl. That is why NaOH is called monoacidic base. So based on the number of hydroxyl group present in a base, we can write that one monoacidic base, second diacidic base, third triacidic base, in case of monoacidic base, the acidity will be 1, because if we take 1 mole of the base, it will react with 1 mole acid. Or we can tell that bases which dissociates in aqueous solution to produce 1 hydroxyl ion per molecule of a base are called monoacidic base. Like sodium hydroxide, potassium hydroxide, all are lithium hydroxide, all are monoacidic base. Now in case of diacidic base, the acidity will be 2, and in this case, when this type of base will be dissolved in aqueous solution or water, it will produce 2 hydroxyl ions per molecule. We can think about calcium hydroxide, magnesium hydroxide, they are called diacidic base. Next, triacidic base, ferric hydroxide. When this type of base we dissolve in water, that will produce 3 hydroxyl ions per molecule. So in this way we can classify the base depending upon the acidity of this base. Next we will discuss the classification on the basis of strength. On the basis of strength, we can classify base into 2 categories. One is called concentrated base, one is called strong base, not concentrated. One is called strong base, another is called weak base. Strong base example will be sodium hydroxide, weak base is ammonium hydroxide. Now why one base is called strong and another base is called weak? Here, when bases which completely dissolves in aqueous solution and having higher concentration of OH minus, that is called strong base. So sodium hydroxide, if we dissolve 100 molecules in water, that will completely dissociate. There will be production of 100 Na plus and 100 OH minus. But if we take ammonium hydroxide, here there is partial dissociation. All the ammonium hydroxide molecule will not dissociate to produce OH minus. So bases which partially dissociates in aqueous solution and having a low concentration of OH minus ion, that is called weak base. So in case of ammonium hydroxide solution, there will be the undissociated ammonium hydroxide as well as NH4 plus OH minus, and in case of NaOH it will be completely dissociated to Na plus and OH minus. Okay, so now you can easily understand what is strong base and weak base. Next we will discuss the classification of base based on the relative strength, okay, or based on the concentration. One we can tell that concentrated base, another is called dilute base. Now what is concentrated base? A base having a relatively higher percentage of base in its aqueous solution then it is called concentrated base. And if we add water to this concentrated base, then it will become dilute. So base relatively lower percentage of base or hydroxyl ion, then in its aqueous solution, then it is called dilute base. If we think about 2 molar sodium hydroxide solution, that you can understand what is the molarity. Then it is concentrated, but whenever we are diluting to form m by 10 concentration of NaOH, then it is called dilute base. Okay, so in this way you can easily understand the concentrated base and dilute base. Now here one thing you have to understand, the strength of a base increases with dilution, because if we increase, if we add water, if we increase dilution, the degree of dissociation will increase, but the concentration of the base is decreasing because of dilution. Next, we will discuss different types of concept of acid base. One thing in the previous class I have discussed, that Lewis acid. Today I will discuss Lewis base. What is Lewis base? Base can donate electron pair. When base is donating its electron pair, then it is called Lewis base. We can think about ammonia. In case of ammonia, it can donate the lone pair to H plus. Okay, so here it is forming NH4 plus. Now that is why this ammonia is called Lewis base. Actually, this is one electronic concept. Bases are electron pair donor and acids are electron pair acceptor. Next, another concept is there, that is called Bronsted-Lowry or Lowry-Bronsted concept. Bases are generally proton acceptor. If we think about OH minus, that will accept on proton and forming water. So here this is called Bronsted-Lowry or Lowry-Bronsted base, OH minus, because it is accepting one proton and forming water. So bases are proton acceptor. Next, we will discuss about the metal oxide and non-metal oxide. Generally, metal oxides are basic in nature. Why? If we think about calcium oxide, if we dissolve in water, then it will produce calcium hydroxide. Now we know that calcium hydroxide can produce OH minus. That is why it is a base. So calcium oxide reacting with water, forming calcium hydroxide. That will dissociate to calcium 2 plus OH 2OH minus. That is why calcium oxide is base. So any kind of metal oxide that will react with water, okay, will produce base. Magnesium, if we burn in presence of oxygen, that will produce magnesium oxide. Magnesium oxide is basic in nature. If we dissolve or hydrolyze by water, that will produce magnesium hydroxide, that is also a base. In case of non-metal oxides, they are generally acidic in nature. We have already seen that if we take sulfur dioxide and if we add water, that will produce acid, because that acid, sulfurous acid, can produce hydronium ion in aqueous solution. So today, up to this, and hope you are safely staying at home. Please maintain the social distance. Thank you.